Welcome. Dear students, I am Dr. Arun Kumar, Associate Professor, Department of Mathematics, Sai Vidya Institute of Technology. In this video, I will be discussing about how to solve a first order first degree ordinary differential equations using Taylor series method. So first, let us see what is the Taylor series formula. So this is the Taylor series expansion of a function y of x. So y of x equals y of x naught plus x minus x naught into y dash of x naught plus x minus x naught whole square by 2 factorial into y double dash of x naught plus x minus x naught whole cube by 3 factorial into y triple dash of x naught plus x minus x naught whole power 4 by 4 factorial into y4 of x naught and so on. So this y dash of x naught, y double dash of x naught, y triple dash of x naught, etc. are nothing but the values of a derivative at x is equal to x naught. So using this, we can find the value of y, I mean a solution for an initial value problem at a given value of x, and this is called as a Taylor series formula. So let us discuss how to solve a first order first degree differential equation using this Taylor series expansion.
So now we shall start the problems on Taylor series formula. So I'll start with first problem. 1. From Taylor series method, find y of 0.1 considering up to third degree terms. If y of x satisfies the equation dy by dx equals x minus y square, comma y of 0 is equal to 1, correct to 4 decimal places. So this is the problem here. So what is the given data? Given, so this is dy by dx differential equation, and we know dy by dx can be written as y dash. So I'll take y dash is equal to x minus y square. Now we'll write the initial conditions. What are the initial conditions? You know, your x naught is 0, comma y naught. The value of y naught is 1. So this is the given data. Y dash, x naught, y naught. So now I want to find the value of y at x equals 0.1. That means the value of x is 0.1 here. So we know that the Taylor series expansion of a function y of x is given by, it is y of x naught plus x minus x naught into y dash of x naught plus x minus x naught whole square by 2 factorial into y double dash of x naught plus x minus x naught whole cube by 3 factorial into y triple dash of x naught and so on. I'll call this as equation 1. So this represents a general Taylor series expansion of a function y of x. Now using this, you have to compute what is the value of y at x equals 0.1. Now to find this, what are the unknowns here? Y of x naught. Y of x naught means initial conditions. Y of x naught is what? 0. So it is y of 0. Y of 0 is what? 1. That we know already. Now x value is given 0.1. X naught is known 0. So we need only the values of this y dash of x naught, y double dash of x naught, y triple dash of x naught and so on. So these are the derivative values. We have to calculate them. So how to calculate these values? See, to calculate, first we have y dash, or I can say y dash of x, this one, is equal to x minus y square. So this implies y dash of x naught. What happens to y dash of x naught? Put x is equal to x naught. So this becomes x naught minus, when x is x naught, y becomes y naught square. So let us replace this x and y by initial conditions, x naught and y naught. You know the values of x naught and y naught, just substitute in this. So x naught is 0, y naught is 1. So it is 0 minus 1 square. So this gives y dash of x naught, y dash of 0 is minus 1. Simplify this. So this is the value of this y dash of x naught. So next I need y double dash, means I need a second order derivative. So find second order derivative from this. What is y double dash of x? So differentiation of this with respect to x. Differentiation of x is 1 minus. So differentiation of y square. So x power n formula, nx power n minus 1. So I can write this as 2y into differentiation of y is y dash. Right? 2y into differentiation of y, dy by dx, or I can say y dash. So this implies y double dash of x naught becomes what? It is 1 minus 2 y naught dash I can write. So this is equal to 1 minus 2 into y naught. What is y naught? 1. 1 into y naught dash. Y naught dash means already we did here. Y dash of x naught, that is minus 1. So if I simplify this, we get y double dash of x naught. This comes around minus into minus plus. So 1 plus 2, that is 3. This is y double dash. So next I need y triple dash. So differentiate this once again. Y triple dash of x. So differentiation of this with respect to x. See, differentiation of 1 is 0. This term becomes 0. See, here you have to apply product rule and differentiate. So use your product rule. It becomes minus 2y. I'll keep first function as it is. Differentiation of y dash. Y double dash. Then plus into this minus 2y dash into differentiation of y again. So differentiation of y is y dash. Right? So this is by using the product rule of differentiation. So this implies y triple dash of x naught equals, so straight away I substitute the values. It is minus 2 into y. Y means what? Y naught. See, here suffixes zeros will come here. 2y naught double dash, like that. Let us substitute directly. Minus 2 into y naught. What is y naught? 1. Here y naught double dash. What is y naught double dash? We got here 3. Then minus, this is 2 into y dash. Y dash means y naught dash. What is y naught dash? Minus 1 into again minus 1. So this implies y triple dash of x naught equals, see, this is minus 6 and here minus into minus plus, plus into minus, minus. So minus 6 minus 2. So it gives minus 8. So this is the value of y triple dash. So, and already in the problem they said by considering up to third degree terms. So third degree term means up to y triple dash. We did it already. So we got the values. Now let us substitute all these values along with x in equation 1. So substituting in equation 1, we get y of x. What do you mean by x here? 0.1, x means 0.1, is equal to y of x naught. What is y of x naught? Y of x naught means this one, initial value 1, plus x is 0.1 minus x naught is 0 into y dash of x naught. What is y dash of x naught? Minus 1. Then plus x is 0.1 minus 0 whole square by 2 factorial. 2 factorial is 2 into, here we have y double dash. What is y double dash value? It is 3 plus 0.1 minus 0 whole cube by 3 factorial is 6 into, we have y triple dash, and what is y triple dash? Minus 8. So substitute all the values like this. So use your calculator and simplify this. We get the value of y of 0.1. And when you simplify this, the answer for this problem is 0.9137. So this is the value of y at x is equal to 0.1 for a given problem. So this is how we can solve a problem on Taylor series method here. And this is a common procedure for all the problems. Okay. Now we shall discuss the second problem. Use Taylor series method to find y at x is equal to 0.1 and 0.2 by considering the terms up to third degree for an IVP dy by dx is equal to x square plus y square, comma y of 0 is equal to 1. So first given, so here y dash, so means dy by dx, so y dash of x, or I can write y dash is equal to x square plus y square, comma initial conditions are x naught is 0, y naught is 1, or y of x naught is 1. So this is the given data. Now we have to consider a Taylor series up to third degree to solve this problem. And we know that the Taylor series formula of a function y of x up to third degree terms can be written as y of x is equal to, it is y of x naught plus x minus x naught into y dash of x naught plus x minus x naught whole square by 2 factorial y double dash of x naught plus x minus x naught whole cube by 3 factorial y triple dash of x naught, and so on. So this is equation. This is the Taylor series formula up to third degree terms. Now in this, y of x naught value means it is an initial condition. We know the value 1. And x naught, it is 0. We know x, there are 2 points here, point 1 and point 2. Okay. So later at the end, we will substitute point 1 and then point 2. So y dash of x naught, y double dash of x naught, y triple dash of x naught. These are the derivative values we need to calculate. So we'll calculate one by one. First we have y dash of x is equal to, the formula is x square plus y square, the given function. This implies y dash of x naught is equal to, so y dash of x naught means at initial point you have to find its value. So it is x naught square plus y naught square. I means initial values, when x is x naught, y is y naught, substitute here. Now you know the value of x naught and y naught, substitute. X naught is 0, so it is 0 square, plus y naught is 1 square. So this is equal to, see 0 square is 0, 1 square is 1. So y dash of x naught is 1, the first value. Next I want y double dash, means differentiate this. Y double dash of x equals differentiation of this, differentiation of x square 2x plus differentiation of y square, we know it is 2y into differentiation of y. Differentiation of y is dy by dx, or I can write this as y dash. Now this implies y double dash of x naught is, that means you have to find the value of y double dash at x equals x naught, and when x is x naught, y becomes y naught and y dash becomes y naught dash, I mean this value. So I'll substitute the values directly. So this becomes 2 into x, x means x naught now, and what is x naught? 0, 2 into 0, first point, plus the next point, it is 2 into, so y means y naught, and what is y naught? 1 into next y dash means y dash value at initial point, it is 1, calculated in the previous step. So I'll use that value. So this implies y double dash of x naught equals, see 2 into 0, 0, and this is 2 into 1 into 1, it gives 2. So this is the value of y double dash of x naught. Now y triple dash, third order. So y triple dash of x is, differentiate this, differentiation of 2x, it is 2 into x becomes 1, plus now differentiation of this. See here we can observe that there is a product, y into y dash, product terms. So we can differentiate this by using the product rule of differentiation. So let us use a product rule. So I'll keep the first function as it is, 2y. I'll keep this. Differentiation of y dash means it is y double dash. Plus, now 2y dash, we'll keep it as it is and differentiate y. And you know differentiation of y is again y dash, dy by dx. So this is a derivative. Now this is equal to, this implies y triple dash of x naught I want. So this is equal to 2 plus, let us substitute now, 2 into, now in place of y we have to put y naught value. And what is y naught? 1. Into, in place of y double dash we have to substitute y double dash of x naught, that is 2 here we got in the previous step, plus this is 2 into y dash. So y dash we got here, y dash value is 1 into again 1. So simplify this, we get, this is 2, where 2 to the 4, 4 plus 2 6, 6 plus 2 8. So the value of y triple dash of x naught is 8. So this is how we can find the values of this y dash of x naught, y double dash of x naught, y triple dash of x naught and so on. And we need only up to third degree. So we got the values. So let us substitute all these things in equation 1. Substituting in equation 1, we get y of x equals, see here I'll do one small thing here, small correction I'll do, that is in the previous problem along with this y dash, y double dash, y triple dash values, x naught and other things, I have substituted x also because there was only one point given in that problem. So we want y value at only one x. But in this problem, we need to find the value of y at 2 points, point 1 and point 2. So what I am going to do is, let us retain this x as it is in the problem, in this formula. We substitute all other values, simplify, so that we get a polynomial expression in x. And after that, we put x is equal to 0.1, we get first value, 0.2 means second value. So let us do like this. Now substitute now, y of x naught means initial value. What is initial value? 1. Y of x naught means y naught is 1. Plus I'll retain x as it is, x minus x naught is 0 into y dash of x naught. What is y dash of x naught? 1 plus next x minus x naught is 0 whole square by 2 factorial is 2 into y double dash of x naught. And what is y double dash value? It is 2u plus next is x minus x naught means 0 whole cube by 3 factorial is 6 into y triple dash, it is 8. So higher order terms I am going to neglect. Now simplify this. This is 1 plus x minus 0 is x into 1 x. Here 2 gets cancelled. So the next term becomes x square. And this is 2 3s are 2 4s are. So I can write this as plus 4x cube divided by 3. Right. So this is the expression for y of x we got. This is a polynomial. Right. Now I want the value of y at x equals 0.1 and 0.2. So let us substitute now. At x is equal to 0.1. We get the value of y of 0.1. Substitute now. This is 1 plus 0.1 plus 0.1 whole square plus 4 into 0.1 whole cube divided by 3. So simplify this. We get y of 0.1. So for this problem, y of 0.1, use your calculator and simplify. It gives 1.1113. 1.3113. Now similarly, at x is equal to 0.2, we get y of 0.2 equals, put x is equal to 0.2 in this, it is 1 plus 0.2 plus 0.2 whole square plus 4 into 0.2 whole cube divided by 3. So simplify this, we get y of 0.2 is equal to, so use your calculator and simplify, we get 1.2507. So this is the value of y at x equals 0.2. So this is how we can find the value of y at a given point x using Taylor series method. So this is a common procedure to solve every problem here. Similar to the last problem, so we'll take one more, problem 3. Find y at x is equal to 1.02, correct to 4 decimal places, given dy is equal to xy minus 1 into dx and y is equal to 2 at x equals 1 initially using Taylor series method. So this is the problem given. So let us see how to solve. First step, solve, solution. So given, see here the differential equation is given in the form dy is equal to xy minus 1 into dx, right? So I'll rewrite this as, take this dx to the left hand side, it becomes dy by dx is equal to x into y minus 1. So I'll rewrite it like this, so that I can rewrite this as, so you know dy by dx is y dash or y dash of x is equal to, this becomes xy minus 1. So this is the function given, right? Y dash of x we got. And now initial conditions. So here, what are the initial conditions? So you know here x naught is 1, say x is equal to 1 stands for x naught, y is equal to 2, x is equal to 1 initially. These are the initial condition. X naught is 1 whereas y naught is 2, or y dash, this is y of x naught is 2, that is the meaning. Now we have to solve this problem using Taylor series, and they did not mention how many terms you have to consider. So let us consider up to third degree term, minimum up to third degree term, we will use it. So we have a Taylor series formula up to third degree, y of x is equal to y of x naught plus x minus x naught into y dash of x naught plus x minus x naught whole square divided by 2 factorial y double dash of x naught plus x minus x naught whole cube by 3 factorial y triple dash of x naught, and so on. We call this as equation number, say, 1. Right? This is the Taylor series formula. Now we will find the values. X naught already given 1. Y naught, I mean y of x naught, it is 2, the first value. And x for this problem only 1.02 it is given. I can substitute at the end. So I need only these values, y dash of x naught, y double dash of x naught, and all these things. So let us calculate one by one. So y dash of x is, it is xy minus 1. So this implies y dash of x naught is equal to, so put x is equal to x naught and y is equal to y naught. So it is x naught into y naught minus 1. So this implies y dash of x naught equals, see here, what is x naught? X naught is 1 into y naught. What is y naught? 2. X naught is 1, y naught is 2, minus 1. Simplify this. So 2 into 1, 2. 2 minus 1, 1. So the value of y dash is 1. Next, we want y double dash. So differentiate this. Y double dash of x is equal to, so here you have a product rule. Use your product rule to differentiate. So this is y into differentiation of x, 1 plus x into differentiation of y is dy by dx, or I can say y dash. So this is our y double dash of x. So this implies y double dash of x naught equals, so here what happens here, y naught plus x naught into y naught dash when I use the initial conditions. So this implies y double dash of x naught equals, see y naught, what is y naught? 2 plus x naught. X naught is 1 into y naught dash. Y naught dash calculated in the previous step. It is 1. Right? So simplify this. 1 into 1. This is 1. 1 plus 2. 3. So y double dash value we got. Next is third order, y triple dash of x. So differentiate this now. So here we have y into 1, that is y. Differentiation of y is dy by dx or y dash. Plus this one, we have a product here. Use your product rule and differentiate. See, if I apply product rule for this, I'll keep y dash as it is. Differentiation of x is 1 plus x into differentiation of y dash is y double dash. So this is by using product rule. You can do in the reverse order also. Now this implies this is equal to, if you want you can write this as y dash plus y dash 2y dash plus x into y double dash. So this implies y triple dash of x naught equals, so it is 2 into, so I'll substitute the value directly. So y dash means it is y naught dash. And what is y naught dash? 1. So it is 2 into 1 plus this is x into y double dash. So x means x naught, and what is x naught? 1 into y dash. Y double dash means it is nothing but y naught double dash. It is 3. So simplify this. So it is 3 plus 2, 5. So the value of y triple dash is 5. So we got the values of a derivatives. Now substitute all these values along with this x naught and x. X is 1.02 in equation 1. So substituting y of x naught, comma y dash of x naught, comma y double dash of x naught, etc. and x is equal to 1.02 in equation 1. We get so y of x means 1.02. This is equal to first point y of x naught. And what is y of x naught? Y of x naught means y naught. Y naught is 2 plus x minus x naught. What is x? 1.02 minus x naught. X naught is 1 into y dash. Y dash value is 1 plus next x is 1.02 minus 1 whole square by 2 factorial is 2 into y double dash. Y double dash is 3 plus next term, it is 1.02 minus 1 whole cube by 3 factorial is 6 into y triple dash. Y triple dash is 5. So just use your calculator and simplify this. We get 1.02 value. Y value at x is equal to 1.02. So this value comes around 2.0206. So this is the value of y at x is equal to 1.02 for this problem. So this is the procedure of solving each problem in case of Taylor series method. It is a common procedure for every problem here. So I did 3 problems so far. So this procedure you can adopt to solve any problem in Taylor series. So in the same way you can try 2 problems at home. So these are the 2 problems for practice purpose. The fourth one, use Taylor series method to obtain y at x is equal to 4.1 and 4.2. 2 points are given. Means it is similar to the problem number 2. So find a polynomial first, and in that polynomial first you put x is equal to 4.1, then you put x is equal to 4.2 and solve this, complete this problem. But remember, here you have to find dy by dx first. Take these terms to the right hand side, find what is dy by dx, so that can be written as y dash, and then proceed. And fifth problem is a direct one. Apply Taylor series method to compute y at x is equal to 0.03 for an IBP. dy by dx is equal to x square into y minus 1, given that y is equal to 1 at x equals 0. These are the initial conditions, right? So use the procedure whatever so far we have discussed and try to solve these 2 problems, right? So this completes your Taylor series method. This is how we can solve a first order first degree ordinary differential equation using Taylor series formula. All the best. Thank you very much.